serial lines and what exactly fast Ethernet lines are. So serial, it is actually a synchronous communication. It performs a synchronous communication, and Ethernet it performs asynchronous communication. So serial actually it uses clocking for transmitting the data, and Ethernet they use CSMA CD to transmit the data. Right? So when I say clocking, what is mean by clocking? So for example, I have like two devices. One is device A and the other one is device B. They are connected via a serial line. Okay. So now transport layer functions are happening, right? And Mr. A is going to send some data to Mr. B. So A has decided to send around like 10 packets. A has decided to send 10 packets. So now while for sending this 10 packets, these two devices will negotiate the time delay which they are going to take. And assume that A has taken a time delay of 1 minute to send a packet. Right? Now, if it is a serial communication, what happens is when the first packet is being sent, A device will start a clock. Right? It will start a clock and it will run from 0 to 60 seconds. Right? Only if the packet will be sent within 60 seconds. For example, the packet is sent in 40 seconds itself. Now, what will happen is in serial links, it will not utilize the 20 minutes of buffer time which we have got by transmitting this data. So this 20 minutes will just be a waiting time. They will not process the packet immediately, right? But in Ethernet, there is no story like this. So in Ethernet, it is called as windowing process. It's called as windowing. It means, windowing means, so for example, I have A and I have B, right? So now A has decided to send 10 packets. Now these two devices will negotiate with each other. And A will tell that I will send you a set of two packets every time. So first time he will be sending two packets, second time he will be sending two packets, third time he will be sending two packets, and fourth time he will be sending two packets. So in 5 rounds, the communication will be done. Okay, so this is the process of windowing. And this using clocking signals is a process of serial lines. So now what we are going to do is anyway like in a smaller topologies like we have, clocking or Ethernet does not matter because we are not going to send a huge amount of data, right? In lab topologies, we are not going to do anything with huge amount of data, right? In real world, serial lines are not at all preferred. So it is not used nowadays. So it is completely obsolete. Okay, so nowadays we go for either fast Ethernet lines or gigabit Ethernet lines or fiber lines. So this is actually it is like reducing the usage. Most of the enterprise level companies are not preferring to use fast Ethernet because gigabit Ethernet is in trend now. Okay, so now what we are going to do is we will try to achieve this scenario. So we have two routers, one switch, and two PCs. We will try to enable the communication between these two PCs, provided we will also try the communication or we will also try to reach to R2. So this will be our agenda today. So now I have given the Ethernet connections. Now I have to give a serial connection. Now in this model in 2811, the packet tracer will not have any serial modules for us to connect. So now we have to add a module. So let me show you how to add a module. I think I showed you this before. So first you can power off the device and you can add something called as NM8AS. Okay, network module, 8 ports. It is actually a synchronous serial network module. Okay, again power on this device. Now the same thing should be done on the other device as well. So now you have a module for slot for adding serial ports. Now I am adding the serial port. Yeah. So now my topology is ready, right? So I'll tell you what I'm going to do before I go ahead and configure it. So this is going to be 10.1/24. Now this interface is going to be 10.168.10.3/24. And what should be the IP address of the fast Ethernet interface? Can it be 10.4?
Which one?
The fast Ethernet 0/1 of router 1. That is this interface. Can it be 10.4?
Yes.
No. Routers connect to different networks, right?
Oh, no, it's not that 10. I was looking only at the last digits.
Okay. So this is 11.1.
Yeah.
And the serial, what should be the IP address? For the same routers, serial 1/0 interface. So it's very simple. You can remember it like this. So when you say one router, this router may contain as many as interfaces. They can have many interfaces, okay? So here, every interface of this router, okay, should be on different networks. So that is the ideology here. So if this is one interface, then this should be a different network. If this is one interface, then this should be a different network. And this is one interface, this should be a different network. Now, this interface of this router, if it connects to another router, then these two should be on the same network. These two should be on the same network. For example, if I'm connecting another interface on this router, then this should be B1. If I'm connecting another interface of this router, this should be C1. Now, for example, if I connect a switch on an interface, for example, this is D network, okay? This interface is D network. I'm not connecting a router here, I'm connecting a switch. So now all the PCs under this switch should be same as that of the routers, this interface IP, D interface IP. Okay, this is the logic. So now this should be a different network. I'll say it is 12.1/24. Now coming to the fast Ethernet 0/0 of this router, that is router 0. It is 192.168.11.2. So these two interfaces are in the same LAN. That's why they have the same IP address. Not same IP address, same network. Okay. So now we will configure all these steps in the devices. I'll start off from PC1. Now on this router, so I have three interfaces, right? I'll first name this router so that we will not get confused. I'll make it as host name. I'll make it as R1. Okay. So this router has three interfaces. One is 0/0, 0/1, and serial 1/0. So I'm going to configure all the three interfaces. Yeah, first interface is configured and it has turned green. Now I got an indication that it has changed state to up. So now the interface is also up, the line protocol is also up. So last class we were discussing about the command, right? Show IP interface brief, in which we had two columns. One is status and another one is protocol. So status is a layer 1 status and protocol is layer 2 status, layer 2 or layer 3 status. Now in our case, both the interfaces are, both the status, layer 1 and layer 2 are up in state. So now on the second interface, now the second interface is also configured. Now it says the physical layer status is up, but the logical layer status is still not come up. Now I'll execute the serial command. The command is always same. Okay, only you just want to change the interface names there. Yeah. So now I executed the command, but still it says down because it's not completely up. I have to enable the other side also.
Yeah.
Now I'll configure the host name as R2. Now I'll execute the show IP interface brief command. to check the status. So now you can notice here the interfaces that we have used in this topology are up in state. Both the status are up. Status is also up, protocol is also up. Okay. So now we will do pinging. We will try to check what is reachable and what is not reachable. So now I'll try to reach my neighbor PC, which is in my same network. So the PC which is nearby me I'm able to reach it. Okay, I'll try to reach my default gateway. So I'm able to reach the default gateway also. Okay, now I'll try to reach the other interface of my router 1. So I'm able to reach the other interface also. Okay, I'll try to reach the serial interface. So I'm able to reach the serial interface also. So now I'll try to reach my R1. Sorry, this is R1, right? This is R2 for us. So I'll try to reach the fast Ethernet 0/0 of R2. Yeah, so now see what happens. So now I'm not able to reach to R2's interface. So what is the reason behind it? Why I'm not able to reach that? The reason is there is no routing configured, right? So for you to reach to a different network, for a PC to go to a different network, okay, two things are required. One is there should be a default gateway, which we have already enabled. And the second factor is we should have routing configured on the routers. Okay. Now, when my PC sends a packet to 11.2, okay, so I'll take a pin. This is my PC 0, this is my PC 1. I have a router here, I have another router here. These both are connected. I have a switch. So this is my topology. Okay. Now he is sending a packet. Now this PC is sending a packet. In this packet, what all the details are available? What are all the different details that are available? They will be having the source MAC address. They will be having the destination MAC address. They will be having source IP address, and they will be having the destination IP address. So all these details will be present in the packet that is sent by this PC. Now this packet goes to the switch. So switches cannot read the IP address. So switches will only read the source MAC address and destination MAC address, and they will understand from where the packet is coming from and to where the packet should be sent. Now the packet has reached the router zeros fast Ethernet 0/0 interface. Now the packet is sent to the default gateway. Now after the packet is sent to the default gateway, now for this router, all these three interfaces. So that is, in our case, this is 11.1, right? This is 12.1. So now when I'm sending a traffic to my destination IP address of 12.1, now this is the router which is going to handle my traffic. Now for this router, all these three interfaces are directly connected to them. It means they are the router's interfaces. They are not someone's interface. It is himself. The interface is owned by himself. Now, to the directly connected interfaces, he can do a routing automatically without any configuration. Without any additional configuration, he can directly send the traffic to all its directly connected interfaces. But for this interface, uh, for my interfaces which is marked in yellow, for this interface, these two interfaces are not directly connected. Correct? They are not directly connected. They are remotely connected via these interfaces. So they are not part of 0/0. They are not part of this router. So now for this router to forward the traffic here, he cannot use its directly connected routing because they are not directly connected. They are remotely connected, right? They are connected via fast Ethernet 1. They are not directly connected. So what happens is routing has to be configured on those routers. Okay. So once we configure this routing, then we don't have any problem. Then the connectivity will automatically get enabled. Okay. So before going into the routing concept, now I said directly connected. If the routers are directly connected, if the router is having its own interface, then there is no need of routing, extra routing to be configured, right? They can do it automatically. So how are they doing it? They are using a protocol called CDP. CDP stands for Cisco Discovery Protocol, right? So this protocol is going to facilitate the directly connecting routing behavior of each and every router. Okay, so with the help of CDP, you can discover your neighbors. Okay, you can discover your neighbors. So that is the idea of CDP. Okay, so now we will execute the commands and check how CDP is working. Now on this router, if I execute the command show CDP neighbors, so now you can notice here this router is telling these are the devices which are neighbor for me. I have a switch which is my neighbor. I have a router which is my neighbor. I have a same router which is my neighbor via a different interface. So now you see we will compare the output and we will compare the diagram. So now if you see, my switch is connected to fast Ethernet 0/ interface, right?
Okay.
The host name switch is connected to fast Ethernet 0/0 interface. And my router 2 is connected via two means. One is I am having a serial port and the other one is I am having a fast Ethernet port. So it is telling I'm connected via my fast Ethernet 0/1 and I'm connected via my serial 1/0 also. Okay, and this is the output of this particular command. Okay, so this command can be used to discover the entire topology. So now, for example, you are working in a medium scale organization where they have 100 routers and hundreds of switches implemented. Now, as an administrator, you are getting access to one router, right? You are getting access to one router, and you are in that router, and you want to figure out who are your neighbors. So, what is the meaning of word neighbor? Neighbor means any devices that are directly connected. So now if you see here, for my router 1, router 0 is directly connected and switch is directly connected. So CDP will give you an output about only the directly connected devices. It will not talk anything about remote devices. Now this CDP is not talking about who is this PC, right? Now if you are executing CDP in the switch, then it will not talk about who is router 2 for us. So now I'll just do it. Just see, I'm on the switch console. right? It is only talking about router 1. It is not talking about router 2, because router 2 is connected via router 1, right? They are not directly connected. So every CDP command that you have executed will only connect or give you details about the directly connected device. Right. So now we will go deeper into this command. What all the different fields that this command covers talks about. So this is your local interface. Meaning is the device from where you are. Like for example, if you are executing on the router, then it will first show you from where you have executed. I am executing from R1, right? So this interface is R1's interface, the local interface of that device. Okay, and you have a field called capability. So capability means uh, what is your neighbor device capable of, right? So when you say like I'm a neighbor of a switch, what is that neighbor device capable of, right? Is it capable of doing switching only, or is it capable of doing routing and switching, or is it capable of doing routing only? So it'll show you the details. So now I'm getting a capability of S. S means switch. So this is a switch only. It's not a router come switch, or it is not a router also, it is a switch only. Okay, so now we have R2. In R2, my local interface is fast Ethernet 0/1, and capability I'm saying it is a router. So it is not a switch, it is a router. Okay, and platform. What is a platform? Platform can be verified by using this command, show version. Okay, see here, this router is actually a C2 Cisco 2800 router. So platform means model of the device. That is what platform is. Okay, the model of the
Okay.
device that you are using. And port ID is the remote interface. So now I am talking about the details of R1, right? So if you take this switch, the local interface is fast Ethernet 0, and the remote interface is fast Ethernet 0/3. So that is what this fast Ethernet 0/3 is. Okay. And what is this hold time? Okay. So now to explain this hold time, we will go back to some basic explanations. So every protocol that we use, okay, so they will be having something called as a hello timer. Some protocols will be sending periodical hellos, and some protocols will be sending only triggered hellos. So what is a periodical hellos? Periodical hellos means, so now when these two devices are connected, when any devices are connected, now this router wants to tell him who he is, right? At the same time, this router also wants to tell who he is. So both the routers are trying to exchange the informations between themselves. So this exchanging of informations is happening with the help of hello packets. And the timer that you take is what hello timer is. Okay. Now this CDP protocol has a hello timer of 160 seconds. It means every 160 seconds they will be sending some kind of information to the neighbor device. Okay, that is my R1 will say I'm connected to R3 to R2, and R2 will say to whom I am connected to R1. So both of them will be exchanging the some kind of information, right, for every 160 seconds. So it is like so for example, you are calling to your friend, right? So if your friend knows you, then you will not explain who he is, right? If your friend does not know you, if you are calling to a new person, right, then you have to tell him who he is, right, who you are. Only then he will be able to understand who you are and what you are going to talk about, right? So hello is nothing but a introduction packet that a router sends to another device. Okay. So now, for example, if this is my topology, so I'll take a fresh sheet. So this is my R1, my R2, my R3. So all these routers are connected like this. So now we'll go step by step. So first step is R1 will send an information to R2. Okay, about himself. Now R2 will send information to R1. At the same time, R2 will send some information to R3. Now R3 will send some information to R2. Now here 3 to 4 will happen. Again here 4 3 to 3 will happen. Now after this first step is successfully done, when all the routers has exchanged their informations with their neighbors, now if you go and see the database of R1, the database of R1 will have details only about R2, correct? Now if you open the database of R2, they will have details about R1 plus they will have details about R3 also, correct? Because
Yes.
this router also has shared and this router has also shared. Now in R3 stable, there will be information about R2 and R4. And in R4 stable, they will have information about R3. Now, each and every router has got the neighbor's information. Now, next step is again they will exchange. Now, R2 will do an exchange to R1. So, after this exchange, what will happen? It will know about who is R2 and it will know about who is R3 also. Correct? Now, R3 will send an exchange to R2. Now, this information, like it will know about R1, it will know about R2, it is himself, R3, R4. When everybody starts exchanging between themselves, each and every router will have an idea about who is the other routers. So after some timer, after some cycles, so you can say like 3 to 4 cycles. Okay, generally it will not happen 3 to 4 seconds. It will happen very fastly because nowadays routers are very smart. So they have the dynamic function of operating. So it will happen very soon. Okay. So theoretically, after some 3 to 4 cycles of data, R1 will have info about R2, it will have info about R3, it will have info about R4. Same case R1, R3 and R2. So every router will have some information about themselves. Okay. Now this is what a hello process is. Now assume that my router is sending a packet. He is sending my hello packet. Okay. Now my R1, so he is my good friend. He is sending a hello packet. Now this router is somewhat busy in processing other packets. So he is not directly hearing what R1 said. He is thinking about something else. So he is busy with something else. Now what happens? This R1's hello packet that he has sent will reach to R2 and it will be waiting on R2, right? That waiting time is what hold on time is. So how much time they can wait? They can wait only 160 seconds. They cannot wait more than 160 seconds. So this packet will stay on R2's interface for 160 seconds for R2 to take it and process. If R2 is not at all responding for 160 seconds, immediately what will happen is it will discard this packet and R1 it will say R2 is not at all my neighbor. So R2 is not connected to me because he is not responding for all my queries. So he is not my neighbor. So if someone sends a data to him and if I am not able to forward the data, there is so I'm not the one who has the trouble. So that is what R1's idea is. So R1 will not take any responsibility. He will immediately announce that he is a dead router and he is not my neighbor at all. Right?
Okay.
So now, for example, like after some 5 seconds, so after some few seconds, again R2 comes back. Again R2 comes back and R2 sends R1 that I'm here. Okay, will R1 learn that? So R1 will learn it. So they will again recreate a friendship.
Okay.
But at least for 1 second of time, there will be no data flowing between R1 and R2, and R1 will go and tell to all the routers, right? So routers are like what they do is they do not keep an information by themselves. They'll if something goes wrong immediately they'll go and tell to everybody. So now for example we have R3 connected here. So immediately it will go and tell boss R2 is dead. R2 is not my neighbor. And immediately R3 will go and tell his neighbors. So their neighbors will go and tell their neighbors. So their neighbor will go and tell their neighbors. So if this router misses one single update or a hello, then it is going to lose data for some amount of time till it regains the neighbor relationship with the R1 device.
Okay.
So now here hold on timer is nothing but how much time my packet is going to wait. My CDP packet is going to wait. So that is what this hold on timer is. Now after 123rd second, the packet will expire. Okay, and again a new packet will be sent. Right? Okay. So now we'll discuss what exactly routing is. Now I use this term, right? So people call it as routing. There are different names for this. So routing is nothing but finding best path to a destination. Finding a best path to reach to a destination. Right? So how do I find a best path? So before selecting a path, a best path, you have to calculate all possible paths to reach to a destination. Reach to a destination. Okay? To calculate all the possible paths to reach to a destination, you have to know which all paths will lead to the destination. That is, you have to know the entire topology. Right? To know the entire topology, we have to know who the neighbor is. Right? So first I will, for example, like I'm put into a classroom. Okay. So I'm sitting in the first bench. Okay, I'm sitting in the first table. So now, to whom I'll talk? I'll not talk to the guy who is sitting in the last, right? I will first talk to my neighbor who is sitting next to me.
Yeah.
So first I'll make him as a neighbor. After making him as a neighbor, from him I'll learn the entire topology. Just now I told routers will exchange the informations and then they'll know about the entire topology, right? Now the entire topology will be ready. After calculating the entire topology, then it will see if I want to go to the last bench, what are all the different routes available, right? What are all the different routes available? So I will first sit and list down all the routes. Now from the list of all the routes, I will select the best route for me, right? So this selection of best route or election of best route is done based on some factors. So these factors are called as metrics. So using this metrics, I will find out a best path. So now, for example, I want to travel to a location. Okay. So now I'm planning to travel from India to Canada. Okay. So what I'll do, so first I will see what is the maximum time that I'm going to travel. Based on the time, I'll go across and search for multiple flights. Right? So I'll have flights with which has lesser timing but higher cost. Right? I'll have some flights will be of more time. It will take more time to reach to a destination, but the cost will be very less. Right? So every time I'll not think about the cost, right? So for example, if my company is to sponsor my travel, then I'll not bother about my cost, about the cost at all. I'll ask them to book a very good ticket. So if I am going to travel, then I'll from my own pocket, then I'll think about a little bit about cost, right? So depending on some factors like this, so what I said, time is a factor, cost is a factor, right? So like this, routers also consider some factors, and routers is going to select a best path. So for to know to select a best path, first the router should know what are all the different possible paths that I can use to reach to the destination, right? So if I want to go to Canada, what are all the different routes? So do I want to go to US first and then go to Canada? Or do I want to go to Singapore first, then go to US and then Canada? Or do I want to go to Sydney and then go to Canada? Or do I want to go to Antarctica and then go to Canada? So I'll be seeing different options, different possible routes. Then from the list of possible routes, I'm going to apply this matrix and I'm going to find the best path. Right? So this is what routing is. So this is a step-by-step process. So even if one data of a router is not properly learned, then your entire routing will fail. So as a network admin, we have to make sure that the router is learning all these four informations properly. So the first one is information about neighbor. So all these informations about the neighbors will be put into a table called neighbor table. Neighbor table. So the next is from the neighbor information, I am going to learn the entire topology. Now this will be put into a table called topology table. So from the list of topology or the how the diagram is, how the network is looking like, I will go ahead and select the possible paths to go to a destination. Now, from the list of possible paths, I will apply metrics. I'll apply metrics and I'll create a table, and this table is called routing table. Okay, so three tables are playing a vital role here. One is neighbor table, topology table, and routing table. So routing can be defined as selecting the best path or election of a best path. How it is being done with the help of metrics. Now, what are all the different metrics that a router uses? So the first metric is distance. So distance is measured in hops here. It's not kilometers or meters. It is actually hops. So what is a hop? So if this is my setup, so this is a hop.
Oh, okay.
This is a hop. So these two is not a hop because they are in the same router, right? They are not a hop. So now for R1, R3 is two hops away. Okay. The next one is load. So load in the sense how much they are going to, what is the size of their packet. That is what your load is. And the third one is bandwidth. So what is the bandwidth of this link? So for example, this link says this is 100 Gbps links. And this link says I'm just 256 kbps links. Right? Bandwidth is your third factor. And the fourth factor is frequency. Sometimes this is not considered as a metric, so I am not taking frequency as a metric here. And fifth factor is cost. So cost is 10 to the power 8 divided by bandwidth. And the next is speed. Okay. Then MTU, maximum transmission unit, 1500 bytes, right, in our case. And the last factor is reliability. So using these metrics, routers will calculate the best path to reach to a destination. Okay. Now, not all the metrics will be used. It depends on protocol to protocol. So some protocols uses only one metric. Some protocols uses combination of multiple metrics. It depends on the protocol that we use. Okay, so you cannot what is it like? You can make a protocol to use a metric also. So, for example, a protocol A says that I'm using 4 different metrics. You can go into this protocol and you can fine tune and you can say that I don't want you to use 4 metrics, just use 2 among them. Don't use all the 4 because I have not implemented everything. Just use only 2 metrics on the list. So you can go ahead and fine tune the protocol as well. Now we'll discuss about different types of routing. What are all the different types that we have? So routing is generally of 3 types. One is static routing, another one is dynamic routing, and default routing. Okay. So static routing is something like it's a manual routing. So for example, you have to travel from A to B. Now you as an administrator, you know the route. So without taking any help of a person, any help, you are just configuring the router and you are making the router to go directly to the best to the destination. So the route is decided by the admin here, right? You are not using the technology which I said. You are not using the steps which I said. So no neighbor table is created, no topology table is created, but routing table will be created. Okay, the routing table is created by the administrator itself. Okay, now what is default routing? Default routing is routing to an unknown destination. What is it? The statement itself is confusing, right? How can I go to an unknown destination? I don't know where my destination is. How will I go to it? Right? So let me take an example. Now you have a PC in your house. So you are connected to modem through which you are connected to a router, and this router is connected to a internet service provider. Right? Now this ISP will be connected to another ISP and through which you will be connected to www.google.com. Okay. So for example, now when I am typing www.google.com, right? So will I know to which server my traffic is going to get redirected? No idea, right?
No.
So now, for example, so now if I do a ping.8.8.8, I am able to reach, right? So do I know where exactly this 8.8.8 is located? No idea. So now if I'm pinging to the Google website, oh sorry. So now I'm reaching to this particular IP address, right? So this is my IP address of Google. Yeah, see, my request has gone to US, right? The
Yeah.
server which is located in US, right? So I don't know how it went. So it is actually like it is in this location. So I think it's nearby Kansas. So this is the area where your the Google server is located, which I have tracked now. So if I try this command after an hour, right? After an hour or after 15 minutes or 20 minutes, then my IP address may change. May change. I cannot guarantee that. Right? Even sometimes it will change immediately. We'll check. Now it's the same IP. So after an hour, if I reset my router, then immediately the IP address may change. So how this is happening? This is happening with the help of this default route. So what does the default route means? Now my PC is requesting to go to www.google.com. It is requesting to go to google.com, and this request has gone to my router. It has gone to my router. My router will immediately go and check his routing table. It will go and check his routing table. It will see, do I have any routes to go to google.com destination? If it has the route by any chance, right? By any chance, if it has the route, then no problem. Immediately, my router will instruct my PC to use that particular route. Now, if it does not have the route, then what it will do is it will take this as a request and it will again send the packet to the ISP. Okay, ISP again, the router present in the ISP will take this request and he will go ahead and see his routing table. Right? He will see whether do I have any route to reach to google.com. If he has, then he will pass it to my router and my router will give it to me. If this guy also does not have, then he will ask his own friend. Right? So this is something like routing by rumors. Right? So I do not have any details to go to the destination. So I'm asking my friend. So if my friend has some details, then there is no problem. I don't have any problem at all. My friend can help me. If my friend also does not have any details, then I want him to go and ask his friends. Right? So provided they should agree for that. Only then that will happen. Right? So if some guy is mischievous, okay, in between, and he is giving me a wrong route, then what will happen? Right? So there can be some cases like this also, right? So for example, I'm requesting my ISP. My ISP is a good guy, so he does not have any problem. So he is telling that I don't know the route. I'll go and check it with my friends. So my ISP router is checking with his neighbors. Okay, the neighbor who he is connected to is giving a wrong route to him. Now my friend, he will never cross check these details. He will directly come to me and say this is what the route given by my friend is. So I just want to take that route and I have to travel. Right? So there is no cross checking involved. So default routing uh, is a method of routing which are used to reach to the servers which are where you do not know where the location is. But this cannot be a, what to say, a valid method. You cannot believe all the information is given by one single router, right? So there can be issues, or there can be losses, or there can be some troubles when you use default routing. So it cannot be guaranteed as a best method. So that is what default routing is. Manual routing, it is done by admin, right? So for example, so now I'm sitting in office. I just want to go to my house, right? I know the route. I don't have any problem, right? I know what will be the time taken. So if I travel via four-wheeler, what will be the time taken? If I travel via two-wheeler, what will be the time taken? If I go by walk, what will be the time taken? I'm having all the details with me. So without asking anybody, I'll just get on the road and I'll start using my transport and I'll reach my home. Right? So it is the decision is taken by the administrator itself. So whatever goes wrong, the responsibility is also should be taken by the administrator. But default routing is not like that. For example, I'm in my office and I want to go to my house. I have forgotten the route, right? So I'm asking my colleague. If my colleague has the proper detail, then he will give me. If he does not have a proper detail, then he may not give me. Or if he wants to just make me to roam around, then he may bluff some details. So default routing cannot be guaranteed at all. So between these two routes, these two types of routing, we have another type called dynamic. Dynamic is something, first an admin, what he does is he configures a protocol. That is, he teaches a protocol. He gives necessary information for a protocol. And this protocol is helping the admin to find paths. Right? So now, for example, to go to my house, I'm hiring a cab. Right? So I'm using Uber and I'm hiring a cab. So what will the Uber driver ask me? The Uber driver will ask me what is the destination you have to travel. First, I have to give him the destination, and next he'll ask me in which route should I go. If I know the route, then there is no problem. I'll give him the entire route. If I don't know the route, I'll give him some idea. Sir, you can take the first left, or you can just take this first right, or you can follow this bus which is going before. I'll give him some kind of information. Using the information which I shared, the Uber driver will take me to the house. Right? So that is what dynamic routing is. So dynamic routing is something like I'm using an agent to go to my destination. So what is the agent here? The protocol is the agent. A protocol, can it work without any input? The answer is no. Administrator should configure some input. There should be some input given to the protocol, and then once all the input is being given, once the protocol makes all the tables ready, then immediately they'll help us to find the best paths. Right?
Okay.
So any doubts in this?
No.
There's anyway theory, like once we get into the practicals of configuring these static, dynamic, and default, then you'll have a better understanding.
Okay.
Okay. So anyway, what I'll do is I'll save this topology so that next class we can use the same. Okay. Okay. So we'll discuss about. We'll see some more theory about these pre-routing, and then we will go to the practical next class.
Okay.
Okay. Okay then. Bye bye. See you tomorrow.
Oh, bye.